At the end of our last video, we were trying to answer the question, does a series converge? And here are the ways that we can try and answer that question. There are a bunch of tests, and one at a time we can check and see if that test can answer the question. Sometimes we'll be able to answer it very quickly on the first test. Sometimes it'll take us a few tries. What I'm going to do is give these tests to you in the order that you should try them, because they are the order from easiest to hardest. So we'll start with the easiest one first. It's called the nth term test. It's a pretty simple one. If you're adding up terms, term 1 plus term 2 plus term 3, if you want them to equal something in the end, to have a finite sum, well, then the terms have to keep getting smaller. If you add 1 plus 2 plus 3 plus 4 and keep going like that, well, of course you're not going to have a finite sum at the end, because you're going to keep adding more and more numbers. What you need is for the nth term to approach 0. So if the nth term does not approach 0, the series must diverge. That should be the first test you check, because it's the easiest. Here's an example. The sum of 2 plus 1/2 to the nth, so that's 2 plus 1/2 to the first, plus 2 plus 1/2 to the second, so it's 2.5 plus 2.25 plus 2.125, etc., etc., etc. If you keep going like this, sure, the 1/2 to the nth part gets smaller and smaller and smaller, but you're still going to keep adding 2 plus 2 plus 2 plus 2 every time. Which means your sum is going to keep getting bigger the more terms you add. There's no way this series can converge. That's an easy one. That series diverges. One thing that's really important to note, you can't say that a series does converge because its nth term does approach 0. That's not good enough. If the nth term does approach 0, the series might converge, but it might not. We don't know yet. Haven't proven it yet. The nth term test can only prove divergence. The next one can prove convergence. It's called the alternating series test. And I will say that this happens to be very common on the AP exam. They love this one. So the alternating series test is a set of conditions. If they're all met, then the series converges. So condition number 1, if the signs of the terms alternate, positive, negative, positive, negative, positive, negative. That's why we call it an alternating series. And the absolute values are strictly decreasing. So something like 1/2, and then negative 1/3, and then negative 1/4, and then, positive 1/4, and then negative 1/5, where each term, forget about whether it's positive or negative, but the absolute value of each term is decreasing, and more than just decreasing, it is approaching 0. Notice how those are two slightly different statements. An absolute, the limit of the terms can be 0 even if the terms are not strictly decreasing. If the terms, we've seen functions whose limits are 0 even though the values get bigger and smaller. So if you have a function, this isn't exactly the same idea, but a function that goes like this could have a limit of 0, but the absolute value of the terms might not be strictly decreasing if we have this is one term and then that's the next term. Even though over time the terms get closer to 0, 2 consecutive terms might not always be. That's why we need these 3 conditions to be listed separately. In practice, it doesn't end up coming up that often that there's a difference between them. If all 3 of those conditions are met, then the series has to converge. And here's the classic example of that. Alternating means we see that negative 1 to the nth, or in this case, negative 1 to the n plus 1. It doesn't really matter whether it's n or n plus 1 there. Either way, you'll have alternating signs. And so this series, over n, this series 1 minus 1/2 plus 1/3 minus 1/4, this series converges. In fact, this one has a special name. It's called the alternating harmonic series. So if you ever come across this one and you just say the alternating harmonic series converges, you can get away with saying that. if you want to say it converges by the alternating series test, you do have to just list the conditions. You have to say the signs alternate, the absolute values of the terms are strictly decreasing with a limit of 0. That's the alternating series test, which is the second easiest one. The next one is the geometric series test. This one might actually be the easiest because we already know it. If a geometric series has an R whose absolute value is less than 1, it converges. We already knew that, so I'm not going to dwell on that one. Those are the 3 easy ones. The next 2 are a little bit more complicated. We'll still put them in this first group. The first is called a p-series test, which means we need a little bit of vocabulary. A p-series, if you look up here, is a very simple kind of series where all it has is n to some power in the denominator. That's called a p-series, 1 over n to the p. So it could be 1 over n to the third, 1 over n to the fourth, 1 over the square root of n. Those are all called p-series. A p-series will converge if that power is bigger than 1. And only if that power is bigger than 1. So this is the p-series of, I'll write it down, 1 over p squared. Sorry, 1 over n squared, because the p is the 2. This series converges because that 2, that p, is bigger than 1. This next one is another p-series, but this time the p is exactly 1. You can write n to the first here, even though you wouldn't normally see it. And that series diverges because the p is not bigger than 1. So this test, unlike the nth term test, which could only prove that a series diverges, or the alternating series tests, which can only prove that a series converges, this p-series test, it can be used to prove either way. The only problem with a p-series test is this is a very, 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 very limited type of series. This last one, by the way, 1 plus 1/2 plus 1/3 plus 1/4, it's called a harmonic series. We'll talk about that more in just a second. But I wanted to point that out because you might have noticed that the alternating harmonic was 1 minus 1/2 plus 1/3 minus 1/4. That series converged. If it's not alternating, it diverges. And then the 5th type of test is connected to that. It's called a harmonic series test. It's an easy one. It's just that a harmonic series diverges always. Of course, that begs the question, what is a harmonic series? It is the series of reciprocals of an arithmetic sequence. So if your denominators make an arithmetic sequence, then the series of fractions is called harmonic. For example, this 1 plus 4 to the nth, that makes up a arithmetic sequence because every term is 4 bigger than the term before it. 1, 5, 9, 13, 17, etc. If you remember back to Algebra 2, we learned that linear functions and arithmetic sequences go together. That's what we're seeing here. The reciprocal of those terms, 1, 1/5, 1/9, 1/13, diverges. Even though these terms are definitely getting smaller and smaller and smaller and smaller, they're not getting smaller faster enough. So the limit of the, like if you keep adding forever and ever and ever, you will actually keep growing forever and ever and ever also. The one I showed you before, 1 plus 1/2 plus 1/3 plus 1/4, that is an example of a harmonic series because 1, 2, 3, 4 is an arithmetic sequence whose common difference is just 1. So now we have these 5 different series tests. And what we can do, I'll do this in the next video, is use this to kind of finish off where we left off with the problem before, where we can check the endpoints.